Hank joins us with over 30 years experience at Johnson Controls and Whirlpool, leading and managing global design engineering, product engineering teams. And Mark Rushton is Senior Product Marketing Manager here at aPriori, focused on design engineering and also sustainability. And joined us from Dassault Systems, where he led product management for SolidWorks. So two very reputable and have a lot of experience in this space. So welcome, thank you both.
Thank you.
Thanks, Chris. Yeah, welcome everyone. So what we're going to talk about for this next session is just to have a discussion around some of the challenges about getting design engineering interested in cost. So we're going to talk about some of the design workflows and when the best time to tackle cost really is. And then look at some of the cost drivers. So where are some of the cost drivers coming from? What are the challenges and the opportunities when it comes to tackling those? Fueling innovation. Innovation is what design engineers want to do best, and we want to make sure they've got the opportunities to focus on that and not worry about cost implications and decisions like that. And then, as we covered in the main stage session in the morning, how collaboration is so key to achieve optimization. So the session is all about design for profitability, and a Forbes and a Tech Clarity study found that 57% of manufacturers surveyed found that students and graduates that were coming to work in design engineering have been very well prepared for 3D CAD. But when it comes to being well prepared to design manufacturable products, that 65% have not been well prepared. So there's a big gap there. So obviously 3D CAD's got very easy over the last few years, and you can create all kinds of different geometries, but sending them to actually be manufactured is where the problem starts from. And as we all know, it's all quoted in everywhere, 80% of a product's cost and environmental footprint is determined in that design phase. So really, we want to tackle cost earlier and shift everything less, because we've got much more opportunity to make significant improvements. But it's a big cultural change, I found. So there's a number of challenges, and Hank's had a lot of experience in several different organizations with many different approaches and different cultures. So that's why we've got Hank with us, as well as him being part of our executive advisory board for aPriori as well. So Hank, what's your perspective on this?
So yeah, thank you all for coming. My experience is that the earlier you get your design engineers involved in taking cost out, the better off you're going to be. I've worked in companies where cost was always one of the metrics that we were being measured against, and we always had product target costs that we had to be making as we were going through a project. The other thing is that many of the products that me and my teams worked on, went to market through retail. And so hitting launch windows when the retailer is going to be resetting their shelves, absolutely critical. And if you miss it, you may not get in until the next reset. So now you have a product ready to manufacture or close to being ready to manufacture that's not going to have any revenue for the next 6 to 12 months. And that's a disaster. And that's a disaster in a retail industry. It's a disaster in an automotive tier 1 supplier scenario. I think you can understand that being on time in many of these markets is really critical. So having the conversations early, doing the trade-offs early, involving the other functions, as you did in the demonstration today, which I thought was outstanding, really can help. One, get the teams to focus on the outcomes for the project from the very beginning. And then two, make sure that you hit your critical to success milestones, both during the project and at launch.
So if you've got a product development team that is currently designing great products, focusing on performance of the product, and then you've got a value engineering team that looks at should costing and things like that, how do you approach the change to get designers focused on it? What are some of the barriers that you've experienced?
I think, it's a little bit about the cost culture within the company, I guess. So in many companies, VAVE is kind of the cost reduction activity. But I think, if you're an engineer and if you run engineering organizations, you know that by the time your product launches, so many of the decisions are locked in, and it can often be really hard to change those decisions, meaning you need to change a model number, which requires marketing literature to be changed, which requires shelf literature to be changed. Everything ripples through. So the opportunity in a VAVE environment, from my perspective, was always, somewhere around 10 to 20% of the overall opportunity within a given product development project. So from my perspective, and I guess in my experience, getting the engineers, the design engineers, the people who are choosing the materials, the tolerances, working with procurement to choose suppliers, earlier the better. Because as you go through development into verification, design changes during verification, again, they just cost a tremendous amount of time and money.
Mm-hmm. Absolutely. And I think that segues nicely onto the next section, which is looking at some of the cost drivers. And a lot of the decisions that are made by design engineers actually are cost drivers. So we'll briefly touch on some of these, like materials and processes, manufacturability, late stage changes, and time to market. They're all kind of things that really have a big effect on cost. So the first one, materials and processes. In your experience, how are they usually selected?
Yeah, so this is an interesting one because different companies, I think, do it differently. In some companies, sourcing is really in charge of the supply base, and the engineers are more about kind of qualifying those suppliers. In other companies, the engineers are more in charge of kind of finding the supply base, and sourcing does the negotiation. So it really depends on what kind of relationship you have with the material suppliers, your component suppliers. Are you having good discussions at the beginning of a project? What could we do to lower costs for you, the supplier, for me, the manufacturer? Again, the earlier you have those conversations, the more kind of robust you can make them with data and using aPriori, for example, to do scenario analysis. Mm-hmm. As we saw in an example earlier today, changing from a molded part to a cast part had a huge impact both on cost and sustainability. How do you get your team to be comfortable going through those kind of what-if scenarios? Having a good tool rather than an Excel spreadsheet can facilitate that quite a bit.
So what would you say the kind of risks are by sticking with what we're comfortable with?
Yeah, I think, again, it depends on the company and how you're operating, but you risk surprises in the market from competitors making different choices than you make. You risk, kind of unintended consequences of not really knowing what the sustainability impact of a given process or location is. I think those are some of the issues.
Okay. So next up, this was a question asked to me, as I was working with a Penn State University. There was a professor there, he's still there, Professor Tim Simpson. He asked an excellent question, and it's kind of really stuck with me. So I wanted to kind of ask the audience this question, and got a couple of giveaways for the best answer. So I'm going to ask Hank to judge the best answer that we've got for this. So I think Chris can run around with the microphone. So the question really is, why are holes round? It might seem like a really straightforward question, but who's got an answer for me? Come on, don't be shy. We're all engineers. We should know why a hole's round.
Because drill bits are round.
Oh, that's good. Do we have any other takers on that?
In traditional manufacturing, a curved edge is a lot easier than a sharp one.
Okay. Say more. Easier how? What do you mean easier?
I would say your tolerancing can be smoother, whereas a corner can have a tight tolerance. So your tooling required, now we have lasers, so it's different, but 10, 30 years ago, it was all about how close can you fit your router bit in or drill straight down.
Any other takers on their perspective? It's a good question. It kind of gets you thinking.
You want round corners rather than sharp corners purely for the reason of stress. Stress will get concentrated if it's sharp, it spreads it on out if it's round, and it is easier to manufacture.
Good answer, yeah. And one more? We got one more answer? Oh, okay.
Oh, come on, you got something different,
Yeah,
right?
that sounds like a cop-out. So there's some great answers there, Hank. It's your
Boy,
choice.
some really good answers. I think we need to reward the first person to speak, because the first person to speak is always the hardest, right?
Absolutely.
And then I think the explanations from the second gentleman were also very
All right.
on point.
We'll make sure you get your aPriori sustainable notepad before you leave. Excellent. So, yeah, well done. Thanks for answering those. So, really, in my mind, it comes down to how we actually make those holes. And I think the drill question, the drill answer, for me, is that's how we create holes. So we should design them in the way that's easy and cheap to manufacture. So it kind of leads on to manufacturability, and I think even the most simple example really gets you to think about the essence of it. And manufacturability is really a huge cost driver, because the number of processes and steps and times, the more complex something is, the longer it takes, you've got more energy, the overheads. And I think there's a real shortcoming, even despite my background. Tools in 3D CAD for DFM are actually quite lacking. You can check, but the onus is really on the engineer to know what value to enter into the check tool in 3D CAD. So there's a big kind of gap there. And I read recently the average age of an engineer is over 50 now. So the experienced engineers are kind of going to be leaving our workforce, and the graduate engineers that are coming in without that manufacturability experience, there's going to be a huge skills shortage. So we do need to close that gap.
I think even in companies that I've worked in over the last 20 years, manufacturing kind of moved away from where the engineers had historically been. And so now you have, whole teams of hundreds of engineers designing products for factories that are hundreds or thousands of miles away. Where is the manufacturing knowledge? And who's having the conversation? And how robustly are you really going through those trade-offs? So in those situations, I've seen aPriori really help to kind of close a gap, whether it's a communication gap or a knowledge gap, relative to being able to really explore what ifs. So as an example, I make vacuums. It's 94% plastic injection molded parts. How many parts should I make per tool? We just had a historical, should I do family parts or should I do just homogeneous parts? These are all questions that have big time cost and sustainability implications. And yet now your engineers are hundreds or thousands of miles away. You're sending an email, you're talking on the phone, you're having a Teams meeting. But are you really getting it done? And I think it's hard to drive that communication. And so one, aPriori has a lot of information built into it and causes you to think about things that you might not normally think about in your spreadsheet-driven world. So that's good. And then two, it facilitates the conversations with manufacturers, whether it's your own manufacturing team or a manufacturing team at a supplier. And it builds your knowledge and confidence in having those conversations. So yeah, I think this is a really important one.
Yeah, and it seems like I've been talking about this skills gap in manufacturability and DFM for probably 15 years or more now. And I think part of the reason is a lot of design engineers are following an academic route, so they're not getting any hands-on experience that they might get from a kind of an apprenticeship. So I think that's a kind of a big gap, really. And it's not one that's going to be closed in the short term. I know a lot of companies try to put their graduate design engineers on the shop floor and give them experience, but as you mentioned, Hank, manufacturing is not necessarily on the same site.
Right.
Have you seen any differences in culture and that working?
Yeah, I mean, language gaps, time zone gaps, they're all real, right? People have to be up in the morning, be up at night on one end or the other to make that work. There's a cost, a physical, emotional, mental cost to that. You know, working with suppliers or your own manufacturing is one thing. Another would be, you know, how should you change what you're doing today? Let's say you're in a situation where you need to move manufacturing for a fairly significant product from point A to some other point B. Yep, you can hire BCG or McKinsey or any number of companies to come and, you know, give you a one-time answer. But building a tool where you can constantly be probing and asking what if is really valuable. And I have the example of moving compressor manufacturing. So this is like a several $100 million move. And you know, the engineers were like, well, we make compressors today, we'll just move it the way it is. And we're like, wait, why? We know our design is too expensive relative to the competition based on all the teardowns we've done. Let's use this opportunity to change the manufacturing so that we take cost out. Without aPriori, we would have been, you know, running in endless loops because we didn't have the knowledge inside the company to say, should I die cast, should I forge, should I machine bar stock? Very simple set of questions, not easy to answer. And where should I do it? Should I do it in China, Vietnam, Poland? I need to explore all those things.
Yeah, absolutely. And mentioning the knowledge in-house, something that's been referenced a lot is sustainability and how it's got the potential for it being an additional cost. Some would say carbon is another currency to assess things in. So what's your take on kind of design for sustainability and the potential skills and knowledge gaps that we might find in design engineering?
Yeah, so I think, you know, I retired about 3 years ago, and so the conversation has really ramped up since I left. But I would say that in the examples that I've seen, your intuition is often wrong, and it can be wrong by quite a bit. And so again, having a tool where you can do what-if analysis and look at different scenarios, you know, who really knows that, you know, all the electricity in company X is generated by coal versus nuclear in another country, and the difference just because of electricity use is massive. Mm-hmm. You know, those are things I'm not sure every design engineer would think about from the beginning.
Yeah, absolutely. And since it's a lot of it's related to customer demand, you know, it's if you don't think about sustainability when you're designing, you're just not going to get the customers. And regulations are obviously putting a lot of pressure on there as well. But what design engineers really want to do is innovate, come up with new ideas. And I think the secret to doing this successfully is validation and being able to fail fast and go in the right direction just by trying out different directions. Have you got much experience of seeing where that's worked particularly well? Or
yeah, I thought the discussion from the gentleman from Eaton this morning was really excellent, because being able to, you know, simulate everything in a digital world before you make big investments or big decisions can really be very helpful. And you know, so I've always been a big proponent of simulation, of model-based design, both for the product and for the controls. And wanting to do that as early as possible from the beginning. Have it be the way we do things rather than a special event or something.
Okay. Yeah, and I think you know, having the digital twin there it makes it so easy to test things and really be able to do things a lot earlier, even if it's just a quick check. You know, not relying on an expert, having the tools to get a yes, no, or a directional result, or just compare two different designs to see which one's best. And talking about complexity, obviously you can't do everything yourself these days. There's a number of stakeholders that go into creating products, and collaboration is vital, really. So a lot of challenges and opportunities are around that. What's your experience in terms of how well it's working in a lot of companies?
Yeah. So one, I think, as you demonstrated in your talk earlier, it really makes a big difference because it saves everybody time. I've worked in companies where the engineers, you know, literally didn't talk to sourcing until they were done. Mm-hmm. Now the sourcing organization has to deal with all the design trade-offs that they made that maybe are not optimum for their supply base. The same conversation with people in manufacturing, right? Oh, I had to make you a more expensive tool because of how you designed your part, and we didn't have a conversation, and now we're out of time. So, yeah, this to me is kind of the goal all the time. Push people to talk earlier with better data and more often.
Absolutely. So yeah, taking that platform approach really does enable agile development. So software companies have been using agile for a number of years, and now I think hardware manufacturers can leverage platforms like PLM, like aPriori, to get all of the stakeholders in the same room, whether that's a real room or virtually, and take everyone's input into the design and really take this holistic kind of design approach just to speed everything up. It really shifts everything left and really enables that agile development. So if you haven't seen it before, I just wanted to jump into a quick video just to show you AP design in action and how well connected to CAD it really is. So using our CAD plugins that are available, in just one click, you can throw that CAD model into the Manufacturing Insights platform, in AP design in this case, and in very few inputs, start to get an idea of cost and carbon. And it gives it in a really lightweight approach, so designers can see exactly what they need to change, whether that's for manufacturability or look at different process steps within the routing. So you get a really good indication of where you're going to get the biggest opportunity to make reductions.
And actually, that you didn't show the punchline there. The result was actually very significant in terms of both carbon and cost reduction.
Oh yeah, absolutely. But yeah, just to summarize, being able to identify cost drivers early, and one thing we didn't talk about actually was time to market and just how brutal it was in some of your previous companies. If you were to miss a deadline,
yeah, your project fails. And
absolutely.
Big problems.
So yeah, and late changes is going to affect that time to market. So all of these cost drivers really do add up, and design engineers have a huge opportunity to make some changes there. And fueling innovation, like AP analytics, as we saw earlier, just being able to identify where you've got opportunities and try different things, being able to try something virtually, get an idea of whether it's going to work, whether it's going to be more expensive. It just allows you to shift everything left, but you need the means to enable that kind of decision making. And as things get more complex, collaboration becomes vital. Using a kind of agile development approach or a holistic design approach allows you to bring in all these multiple stakeholders into the same room, get them all on the same page, learn from their expertise in different areas, and really accelerate the whole process.